Yeah, thanks Susan for the introduction. So I'm Carsten and this is David over there. And now it's working, good. So we didn't do a presentation pitch before the keynote because we thought our topic is so interesting and people will turn up here anyway. And so thanks for being here in this room today. Just as a reminder or as an information up front, this session will be split up in two parts. The first one is a brief introduction of Apache Sling, which I will be doing, and then we switch to David, and he will take us up in the cloud and do all the fun stuff. So mine is the boring part, and his one is the interesting part. And we thought this picture fits very nice with the location here because we have the castle down the road and the nice gardens. If you want to do something different than listening to talks, then that's maybe the place to go. All right, so this talk is about Apache Sling. And Apache Sling basically is a web framework which already exists since 7 years at Apache, which allows you to build web applications, of course, in a REST style, as you will see later on. And then we will take this up into the cloud. And to do that, I think we come up with building the next great web application, which looks like this, which I called Slingshot because it's slingshot, so it's kind of connected. Thanks. And before I go into the details on how this works, I will show you the web application first. Oh, that's nice. So this is the Slingshot web application. I can log in as a user Slingshot, and what this application allows you to do is you can build categories and put just items in it, and then people can comment on it, can rate it, and so on. So for this user, we just have one single category called travel with 4 nice items in it about where this guy lives, his nice view from his apartment, and his nice pet, which he has at home. And so you can look at this item, this pet in this case. It has some comments about what this is, how this pet behaves. You can leave some comments like, hello, this is nice. And then you see these comments at the bottom with a timestamp when this was created. You could also rate this item and give it a rating of 4. Right, so these are the basic features of this application, really very plain and simple. And now, for example, if another user logs in, and this user has the name Slingshot2. Okay, just a typo on the password. And again. Here we are. This one has 2 categories, one for aliens with some strange creatures living out there, another one for some interesting places, somewhere where some aliens might have landed some long time ago. And this user, of course, can go to, sorry about that, to see the stuff the Slingshot 1 user has. I'm pretty bad in typing today. They can also see, because this is all public, can also see the stuff and give a rating of 2. And because the other user gave a rating of 4, this makes up a rating of 3. You could leave comments and so on. So that's, again, the basic functionality of this application. And now let's see how this all works with with Sling. So typically, if you think of URLs, and especially if you have a large product catalog or something like that, you might have seen URLs that look like this. You directly target some code on the server, like a JSP, and give some ID of the real thing you want to see as a request parameter. But that's actually not the way how you should do it, because that's not really RESTful, so just forget about this one. So how should you do it? The best thing is to use descriptive URLs. And for example, to target something like the pet, you really have a descriptive URL starting with the user, with the public area of that user, the category down to the item you want to see. And you also use the extensions to specify in what format you want to see this stuff. So like .html or .json and so on. That's really then more RESTful, because you directly target what you want to see, and you can see by looking at the URL what you want. And this basically gives you a resource-oriented architecture where every piece you can request is a resource, like the user home, the category, an item, the image, a single comment, everything is a different resource which has a unique URL. And by using that, you get some stateless mechanism of getting your stuff, following the REST principles coined by Roy Fielding a long time ago, which basically means the request contains all important information to fulfill this request. And you leverage the HTTP protocol, so you use the get method to get stuff, the post method to update stuff, delete to delete, and all these things which already exist for a long time. And in Sling, you actually structure your data in the same way as you build your URLs. So basically, you build a tree of resources. For the Slingshot example, you have a node for each user. So Slingshot 1 has its own user node. Underneath is a public node. Then the category travel, and underneath that one, the different items with images, comments, and whatever is there. And this also shows you that you can store in this resource tree very small pieces of information, like a comment or rating, but also big, or let's say larger data, like images and so on. All this goes into the tree, and the nice thing is that this tree directly maps to your URL space. So if you want to request this pet JPEG down there, the URL you use is exactly that path to that image. So it's really simple to deal with that. And in Sling, we use something which we call the resource-first request processing. So when such a request comes in, like Slingshot 1, public travel, pet, comments.json, comments.10.json, sorry. This URL is parsed and mapped to the resource in that tree, which is this comments resource there. And then the remaining parts of the URL are split up into the extension, which in this case is JSON, and what we call selectors, which is a 10. And you also have the HTTP method get in this case to get the resource. Once the resource is known, you also know the resource type, which in this case is comments. So every resource in this large resource tree has a type. You have a type for comments, for an item, for category. For each piece, you might have different resource types. And once this is known, the first step of the request processing is finished. So we have resolved the resource. We know what is requested by the user, which format, and so on. And the second step is actually the most difficult one, or the most, let's say, complicated one. Sling uses a script to fulfill this request. And it takes all these pieces of information into account, like the resource type, the HTTP method, the selector, the extension. And it finds a script to execute that, builds an execution chain with a script at the end. There might be additional filters up front, transforming the request or doing whatever. And then this thing is executed. So this is the basic flow of how Sling works. That's why we call it resource-first request processing, because the resource is resolved first, and then the script is found and then executed. So basically, if you're writing a Sling application, you build your content by putting resources into this resource tree, and you write the script, for example, to render HTML. And when it comes to these scriptings, to these scripts, you have a whole variety of choice. You can use JSPs, plain servlets, other scripting languages, everything basically which is supported by the Java platform. And you could write your own script handler if you want to. The more interesting part is that Sling already comes with some default handling for JSON or XML if you need that. So if you want to just put out JSON for your data, it's already there. Nothing you have to do. The same goes with handling updates of your content or creating new content. The post handler is already built in and usually does what you want to do. So there's rarely a need to write that. Which leaves you with just focusing on writing scripts to render your stuff. And just to give you a brief example on how this could look like, this is a script which renders a single comment, which you see on the left how it looks like. And this script just renders the title and the comment and the date and so on. And because of this this resource-first request processing, your script already gets the resource passed into the script, so you don't have to do it yourself. You just use the resource and put out the different informations. And just to give you another short example of that, I switch back to my browser. So for example, if you want to have the JSON format of the comments, which I just added to my pad, you request this resource with .json and get a nice JSON format of it. Or for example, if you want to, it's already visible here, see just the HTML part for this comments block, then you can just directly request just this part because that's a single resource which is rendered by the script I've shown earlier on that slide. So this is just really a very brief and short introduction how Sling works. The basic thing is that this is the resource-first request processing. Oh, by the way, I didn't mention that Sling is all based on OSGi, so it's all coming in hundreds of different OSGi bundles, so you can really customize your Sling application. And you can use the scripting inside and use whatever script you want. As I also said, Sling uses a resource tree to represent or to store your actual data your application is dealing with. And this resource tree actually can be coming from different data stores. By default, Sling stores everything in the Java content repository, where we use the implementation of Apache Jackrabbit. But you could also, for example, just store all images on the file system, if that's your use case. Or for content that is, which has a high frequency of creation, like comments or ratings, you could store just that part in the Mongo database. So this gives you really easy flexibility to structure your data and store the pieces in the appropriate locations. This also Yeah, makes it very easy to store your data and to bring Sling into the cloud, because we have Mongo in it, and as soon as Mongo is there, it must have to do something with the cloud. Now I hand over to David.
Microphone shuffle. I'm not sure if this is even actually necessary, because the microphone is a small room, so do we really need a mic? For the recording, is it? Okay. Right. Okay, so now that you've built your nice Sling application, you want to basically scale it up. You want to deploy it, you want to put it in the cloud, and obviously you want to spend very little money because you're just starting. This is a new application, so you want to start small. But, I mean, your application could become very successful. People like, social applications. They like commenting. They like dinosaurs. It might be a very successful application, so you want to be able to scale it up without having to take it down. You don't want to have to stop your application just to move it to a bigger machine or something like that. So you want to start small, but you want to be able to scale it up without downtime. And last but not least, one of the things that I personally find very important is to stay away from any cloud specifics, details. So you can move your application from one cloud vendor to another without having to rewrite parts of it. So this is what we've done. We've built something like this using OSGi, Sling, OSGi, and some other open source technologies. And this is basically what it looks like. The request kind of comes in down here. It hits kind of a couple of load balancers. You don't really want a single point of failure, so we have that replicated. And the load balancers dispatch the request to where your application happens to be running at that point in time in the cloud. And that can change. So here's two instances of Carsten's application. Both of them talk to the backend database. I didn't really go into the detail of how to make your database suitable for the cloud. There's offerings already that can do that, like Carsten mentioned Mongo, which is a great, highly available offering that you can just use, and it integrates with Sling. You can also use something like Cassandra or an SQL database, or you can even integrate with something of your own choice. So, this is kind of a default deployment, not too busy, not too quiet. It's, normal operation, as I would call it. Another entity that's visible here is this director entity. By the way, that's also not a single point of failure, but I won't get into that right now. The director is basically in charge of the whole thing. So it has a lot of knowledge about your application, what kind of requirements it has, and it can decide how to modify the deployments. It can modify it based on the requirements, the current load, the current kind of situation of your application. So just a brief closer look at what this director does and how it works. The director basically works with these OSGi nodes through OSGi services. So it's really simple. It knows about cloud nodes that are there by simply working with the services, by listening to the services. If a service of the type framework node status, which is, by the way, a service that's defined by an OSGi RFC that we're currently proposing to be a spec. If that service appears, it means there's a new node in your system. And then once you know that node is there, you can provision it, you can make it do things, and you can inspect it, you can look at whatever, whatever's on it, what particular hardware it is on, how it's doing in terms of memory, stuff like that. And you can also use the service to discover that the node is there in the first place, like simply by using OSGi services. Another thing that the director has, it basically is fed in these metrics. Now, the clouds have various ways of providing metrics to consumers of that. It's usually through a back channel. We implemented our own abstraction over that to basically provide a cloud-independent view over that. And these metrics are fed into the director. So with these metrics, combined with what it sees in the current deployment, the director can make changes. And what we've done is we use jclouds, Apache jclouds, which is a great way of creating new compute nodes in the cloud in a vendor-independent way. So jclouds can be used to create EC2 nodes. It can be used with OpenStack, Rackspace. I think jclouds supports something like 60 different cloud vendors. So it's really, it's kind of nice and independent. And basically having a structure like this allows you to get this fluid cloud application without having any vendor specifics in there. So, for example, one of the things that it could do is the director could find that there's a lot of traffic, your application turns out to be a hit. It can decide to add additional nodes to the system, and they don't all have to be the same, right? So in this example, it added a really big one. The cloud director could do whatever it wants, basically, but it could also add, it's not one size fits all. It can integrate with whatever the underlying cloud platform provides in terms of, creating bigger nodes, smaller nodes. Again, that's all going through jclouds. So, busy times, you add more capacity. For the traffic down here, the URLs are still the same because it goes through the load balancer, which is also deployed as part of your cloud deployment. And then, maybe later at night or something like that, the system turns out to be quieter, people have gone to bed, they're not using your system anymore. You can scale it down to, maybe just one node. And the interesting thing is here that, changing your deployment like this, because the director is basically, it's not a human that does it, it's basically a program that does it. This only takes seconds, right? So if your application turns out to be quiet for half an hour, it's already worthwhile changing it like this because you'll save money in your deployment. Like the one thing that actually takes money, I find in these cloud deployments is creating a new compute node. That can take a couple of minutes depending on the cloud provider that you're using. But once the nodes are up and running, changing your deployment is really, really quick. And then you can even go a step further. Let's say there's some really, really quiet times. Maybe this is Christmas or New Year's Eve or something like that. You still want your website to be available, but you don't really need to have it up and running for many users at all. So to basically achieve a very high level of density, basically, of deployment, you can stack multiple deployments on the same node, and we've done this using Docker instances. So you can view this as different tenants, effectively. Previously, it was all the same tenant, the same application, deployed multiple times. In here, I have 4 totally different and totally unrelated Sling applications deployed only on one single OSGi node. So they're there, they're not gone from the internet, but because you don't measure a lot of traffic, you've decided to move them back to Docker instances, micro deployments, where you can have multi-tenancy and a very high level of efficiency and resource utilization. And again, the next morning when traffic picks up again, you can change your deployment again to be larger. So that's really it. It's quite simple, and this is kind of a summary. If you have a nice internet application, you probably want to have make it have a REST API, which actually embodies the business knowledge. Carsten has business knowledge about, commenting on photos. That's the REST API. That could be a killer application. Look at Facebook, it's the next thing. And then you can build your application around that using whatever technology you like. So you can build an iOS app or a JavaScript-based app that is running in a browser, or you can use the Sling scripting to build your application that works with that REST API. And then once you have that up and running, you can use OSGi Cloud Ecosystems, Apache jclouds and Docker to scale it to your needs in the cheapest way possible. So you make money, basically. And you want to be vendor independent, and that can be achieved through these technologies as well. So that's really it. We have a little plug here for another session. If you're interested in OSGi and cloud, tomorrow in this room at 3:15, there's a workshop where we go a little bit deeper into what the OSGi Alliance does in terms of cloud, and we want to kind of gather ideas, hear from people. What they're doing with OSGi and the cloud, how OSGi can be made better, war stories or success stories, whatever you want to share. And we have a workshop in the afternoon here about that topic. Oop. And that's really it. A couple of links if you want to try this out yourself. It's all in open source. Any questions? No question.
Yeah, I actually do have a question because I'm asked quite often, and it is way beyond the stuff that you actually have presented very well. It's about open source per se, because all what I've been to a conference last week that was focusing on IoT and smart home and how it's been combined. Actually, it was my own presentation combining it. Now my question comes from what I've been asked by people, because I'm of course doing both open source and commercial aspects at the same time. So from my point of view, I really would like to get feedback on how you want to defend maintenance costs, further development costs once you use an open source instead of a commercial product and vice versa. So
Okay.
what's the benefit?
So that's more like an open source question. What are the maintenance costs with open source compared to closed source?
Exactly.
So, I mean, my personal opinion on that is, and I'm not really involved in the cost side of things, but my personal opinion on it is that with open source it's cheaper because you have more people working on it and more people looking at it, more people fixing bugs. If you have a proprietary product in a company, there might be 5 people working on it, or there might be 10 people working on it, but they're all paid by this one company. And they're the only people, and typically you have experts within those groups that have their own little subgroups. If you look at many commercial projects, there's usually 1 or 2 people who know something about a particular area and 1 or 2 who know something about another area. Very limited scope. Whereas with open source, you have a lot more people who have the knowledge about the same code base and who can apply bug fixes. And I think it tends to be cheaper to maintain.
My second question actually refers, and then I'm going to roll once again. My second question actually refers to your presentation, taking into account the OSGi IoT demo that has been set up. Knowing that there's a cloud, an OSGi-based cloud already provided by Paramus. There is cloud, well, actually there's a SaaS component, which is the remote management platform provided by Process. Would it be feasible to get your stuff included into the hackathon maybe next time, so that people really can work on it, using it, because we're talking about applications, and they should develop applications.
So it's an interesting thought. I think next time, I don't think you mean tomorrow, but next time we're doing a conference. Yes, I think, I don't know what you think, Carsten, but I think especially the cloud ecosystems concept, basically where you use OSGi services to discover frameworks. Those frameworks don't really need to run in the cloud. They could run on an IoT device as well. So as with many things we do in OSGi, they are applicable to different kind of verticals.
Exactly, that's why I'm asking.
Yeah. So I think we should probably try to include that.
So
And maybe Sling as well. I mean, run Sling in the light switch, would that be a possibility?
Okay, cool. So I've got your confirmation too.
Any other questions from the room? I mean, if people are interested in OSGi in the cloud, I mean, we're doing a lot of stuff there. I think OSGi is already quite useful in the cloud, but we're going to make it even better. So yeah, if there's anyone who has any experience, you can also sit on it and ask us some other time during the conference, or come to the Ballas.
It's not about Sling and Cloud, can we ask?
Yeah.
Do you have any solution for farming? I mean, like you install a bundle for one node, then it's installed for every node, or how do you solve this problem? And the distribution of the configuration of the OSGi server.
So we in the implementation that we've done for this, and we're basically, doing as a research project in Adobe, we have a solution for this. It's basically the director entity knows about all these deployments and sends them across to the various frameworks that are running.
it's about the driver.
A director has knowledge of everything, yes. And how the director is implemented is a little bit of, an implementation detail, but yeah, in generally, it knows about those deployments. So if you have a farm of frameworks that all need the same deployment, then the director takes care of that they all get the same deployment and they all get the appropriate configuration, which could be different per instance. The director is not really open source right now. You could write your own quite easily based on the ideas that we presented here, but there are.
But the part which we use to describe an application, so describes all the bundles you want to deploy to the application, the configurations and whatever goes into that application, that is actually part of Sling. So we have, which is kind of similar to what Karaf has with its features. We have a similar provisioning model, we call it, where you can describe all the stuff, and then we just use the director to launch these applications based on the Sling provisioning model. So this part is all open source in Sling.
Okay.
Well, then,
Oh, Ballas has another one, I think. That's more an Adobe question, right? You want to play with AEM?
Oh yeah, you can. I mean, these are the links, so you can download Sling and then try out the sample application and then bring it into the cloud.
I think Ballas wants to try out AEM as well. AEM is the commercial product that is built on top of Sling.
We can talk about it later.
Yeah. Okay, talk about it later.
thank you very much once again. There's a short break. We'll meet again at 12:05. If you're interested in development and the process of business models, so then